You paper, yeah. I gave you one across there. Look. You got it? Alright, cool. Alright, well, ladies, I guess it's you all on me. Alright, cool. Well, there we go. Alright. Y'all, me, and the gentleman on the Google Meet. Oh, it's Liam. Alright. Hey, Liam, what going on? Right, let's take my role. Come on, Liam. Okay, so Donovan here, Hanifa here, Jane here, Javi, Jaziri, Jolie, Khalifa, Liam, Noah is here, Nyla, Peach. Okay. So more than half the class on the inside. All right. Yeah. Pass side. Olia, still keep it down a little bit more, right? Thanks. All right, good. Right, so folks, good evening. Today we started in May 2023, paper 2. Where the first couple of questions on the screen. Oh, right. All right, 17. Nothing. Supposed to. But that's actually the opposite situation going on right now. Yeah. So, divide and conquer. John 2018 is it, right? Okay. So apparently it's one of the handwritten ones are back in the walk. Give me, how you doing? Right, so as you know, you could use the calculators, right? As okay, screen don't want to move now. Oh, that's great. Right, so while you're, let me just put it back up. Yo. Paper 1, no. So what's going on here, boy? Why it can't zoom in? Oh, it won't depend now. Folks, I'm gonna have to do a quick reset because things don't want to cooperate. So you all go ahead with the paper now. All right. Let me see if maybe just doing a quick reset will work. I can't take on the further party, same thing. All right, TikTok. Just give me a quick minute to do a reset. This thing not cooperating. Upside down now. Lord have mercy. Right. Restart. I guess in the meantime, you can tell some jokes. Why was the vagrant winding up on the dustbin? Because it marked throw waste here. You just walk and you see 3 holes in the ground. What you would say? Well. So funny. I'm trying to make a woman up with a plumber fixing the water tank. Yeah, I did a reset because the pen wasn't responding, then it wasn't responding to Zoom in. I'm kind of mad. So I'm gonna just do a reset and see if things work in. Trying to encourage our viewers. I mean, oops, it's upside down. There we go. Uh-huh. All right. Okay, it's okay. I just probably need a minute again. Yeah, thanks for your patience very much. Who that boy? Right, what do you think on there? Display settings. All right. Keep changes. What? Okay. Yeah, no, you're good. All right. Once this thing holds, I'll be back up and running very soon. So as much as I try to start on time, you can push to 6:45. All right. All right. So first things first. Okay. Pen working. Connect cord. Okay. It blinked, it zoomed out, it zoomed in, and it's back up. Aha! All right, give thanks and praise. All right, cool. All right, so there we go. Oh, very thanks for the art. The rules, sorry. Right. All right, folks, let me go here. All right, so let me go. Let me do with the first two now. All right. So we have 5, 6 plus 2/3 minus 12 over 35, and then by 7 over 9. Now, according to your order of operations, what's the order of brackets, order, multiply, divide? Whoop. Am I doing that thing again? 1 second. Huh? This thing. All right, just now. Come back. No. All right. If it disappears again, I know how to deal with it. But for now, we'll just try it. Right. So brackets, order being powers, multiplication, division, and then addition and subtraction. Okay, cool. So clearly we're doing the multiplication first, then followed by the addition, and then the subtraction. Okay, so let's oh, there's Logan. Oh, there's Logan. Hey Logan, how are you doing? We're now starting some solutions here. We're doing May 2023, paper 2. I send the paper in the chat, right? But of course, everything we're doing will be visible on the screen, right? So if we're doing the multiplication, so basically, we're going to be minusing that, right? The product of that, right? So what could simplify here? 7 goes into 7 one time, into 35 how many times? 5. What about 9 and 12? Can 9 and 12 cancel? Do they have a common factor? 3. That's correct. 3 goes into 9 3 times. 3 goes into 12 4 times. And when you multiply in fractions, you do 4 by 1, which will give us 4, and 5 by 3 will give us 15. Right? Okay. Now, with the addition, right, we need a common denominator. Between 6 and 3, what's the common multiple? 6. That's very good. All right. So you put your 6 there. Right. So this is 6. So we did need to modify the numerator. So you bring your 5 down here. This is 3. What do I need to multiply by 3 to make it equal to 6? 2. And whatever I multiply the 3 by, I have to multiply its numerator by the same thing. And 2 by 2 will give us 4. And 5 plus 4 is 9. Right? So we have 9 out of 6 minus 4 out of 15, right? Now, if you want, you could cancel out 9 over 6 because 3 could go into both of them. 3 into 9 goes how many times? 3, and 3 into 6 goes how many times? 2. Now, guys, if at any point in time you'll see me make a mistake, please tell me, yeah? We're being a little tired, but I don't get vexed if you'll correct me, provided, of course, it's polite and, correct. Right? Okay. Now, between 2 and 15, we need a common denominator. So what we could do here is just probably multiply both of them, right? 2 by 15 will give us 30. Right? So, of course, we multiply 2 by 15. We multiplied 15 by 2, so you have to multiply 15 by 3. Right? So if you want, you could show the work in there, but you don't have to. And we multiply 2 by 15, so we're multiplying 2 by 4 as well. Yeah. When done? Yeah, so time and a half is the rate at which the overtime is paid, right? So you take a regular rate, whatever it is, and multiply by 1.5. Yeah. All right. 45 minus 8 is 37. So you can leave it as 37 over 30 or 1 7/30. Both mean the same thing. All right. Okay, so that's the first item there. Find the exact value of. Right? Yeah, go ahead, Noah. This question is worth 2 marks. That's correct. Yes. Okay, so the question Noah is asking is if he just plugs this into his calculator and puts the answer, will he get both marks? I've asked my friend Cook, who has marked CSEC multiple times, and he says no. He says what to do. You can't just put the answer and get both marks. What you could do, you could put your answer. So, for example, let's put the alternate, right? So, the first line in the working could be, so if you add 5, 6, and 2/3, you will get the 3 over 2, right? So if you put the 3 over 2, and then the product, the 12 over 35 by the 7 over 9, that is the 4/15. And if you put your answer thereafter, right, you can get the full 2 marks from that. Yeah, because you would probably get, sorry, who's asking? Sunflower? Hi, I'm new. Is this CXC Maths? Okay, this is CSEC Maths. This is the May 2023 paper 2. Yeah, because you would probably get like a half mark for this, half mark for that, and a mark for the answer, or somewhere along so, right? Because you'd also get like a half mark for doing the multiplication first, a half mark for doing the addition second, and then a half mark for each of those answers. So you have the marks there, right? Oh, you're most welcome. All right, so, all right, in the interest of kind of keeping things flowing, because I had some technical difficulties, we're just going to go to the next one. So I'm not going to send pics of everything as I go along. I'll just send a PDF afterwards, right? All right, hold on. Oh, I'm not going to see. I'm not seeing some people here. Here's D'Angelo. Let me just listen. So, right. Hey, D'Angelo, good afternoon. Good evening, sorry. Yeah, we're working in May 2023 paper 2. We just with the very, very first question, so we haven't missed much. All right, so I'm now about to go into the second part of number 1, part A. Well, sorry, number 1, part B. All right. Let me know when you're ready for me to scroll down, right? Ready? Okay, cool. All right, guys, I'm scrolling down. If anybody needs to explain anything, let me know. Okay. Right, so calculate the value of this character 3 decimal places. So, right, so this one, again, this one is just, honestly, just calculator food, eh? Because the next thing, I'll show you the answer here, right? So how I would approach this one, right? So I'll do the 37. No, crap, I pressed the wrong thing. 37 cost. You have to square that and then subtract it from 1. Right? So 0.362. So what I would say is that at the very least, you should put the square root of 0.362 ... and square root that now. Boom. So 0.60, right? So you see always 0.601, right? Now they want the answer correct at 3 decimal places. But if you look to the right of that digit, you're going to see an 8. because that is an 8, right? If it's 5, 6, 7, 8, or 9, you have to round this digit up by 1. So it'll actually be 0.602. Yeah. Yeah. 1, 2, 3. Right. So it depends on how you're plugging it in. So what I would suggest, if you plug it in your calculator, if you press the square root sign first, press a bracket. Then press 1 minus. Because if you don't do that, it could throw off the calculation. Right? Zero. All right. All right, let me check it. Right. So there's a way to cross check this, right? So if there are any AdMath students, right, they would know that 1 minus cos squared of anything is equal to sine squared, right? And if we're doing the square root of that, it's equal to the square root of that. So and the square root of sine squared would have to be sine, right? So we're just finding sine of 37 degrees. If you plug that in the calculator, we'll get the true value. So 37 sine 0.601 again. Right. Noah, what I want you to check for me is calculators have two modes when they're dealing with angles, right? And if you're in the wrong mode, it would affect the answer. So it have a degrees mode and it have a radians mode. So if it did that, well, it's totally different. Okay. Send me a picture of your calculator on WhatsApp now, and I'll see if I can take a look at it now. Because different calculators have different layouts. All right, cool. Okay. Ladies, we okay with this? All right. So Google me. So DeAndre Donovan, Liam Logan, and Noah. If you guys are good with the first two questions, let's give them a quick genie chat. Right? So I don't know what's and I'm gonna pick up his calculator so I can take a look and see how to switch between degrees and radians and that kind of stuff. Right? If anybody is having trouble, let me know. All right, so I'm gonna go on to the next page now. We are going to zoom in here. Actually, you know what? Here, I'll do this item here quickly so we could scroll on to the where the money is down there, right? Okay, so 0.00527 in standard form. So standard form requires you to have one and only one non-zero digit to the left of the decimal point. But 5.27 is not equal to this. So we have to multiply by 10. And we have to raise 10 to a power. And that power is how many spaces you have to move this point back till it gets to the original point. So that's here. So we moved it here. So if you look, you have to go back 1, 2, 3 points. So you put a 3. But the thing is, which way is it moving to go back to the original position? It's moving to the left, right? So it's going left 3 spaces. And moving to the left means we need a minus. The minus indicates the direction of travel. All right? All right? You could open the tree. Sorry, question? Right, so standard form requires okay, so a standard is a particular way or means of so for example, if the standard pass rate is 50%, you had to get 50% to pass, right? If let's say you had to make some food and there was a standard to which you had to keep your kitchen or make the food, there's a particular bar level or quality, right? Standard form means you want everything looking the same. It's standard. Like how people wear uniforms to school, they wear something standardized, right? So standard form means you want everything looking the same. And how they do that, the rule is just something we made, it's a construct, if you want to use that word, is there must be one and only one digit that is not zero to the left of the decimal place, right? So you'll never see 52 points something. It always, so for example, if you had a number, let's say 3,691, if they wanted this in standard form, it'll be 3.691. Again, only one non-zero digit to the left of the decimal point. But you have to multiply here by 10 to the power 3. Because the original position of the decimal point would be here. Right. Well, yeah, if you don't know the rule, then you wouldn't know what to do. It's like if you go to a new school. Yeah. All right, folks online, just give me 1 sec. I switch out the cord, so this shouldn't happen again. I do apologize. I know a couple of my components, they're a little old. So they give me one by second now. Right, and you put 3 because you have to move this 3 spaces to the right to get back to the original point. Original position of the point, sorry. Right. Okay. We okay with that one? Right. Okay, so let's scroll down. Right. So I'm gonna just zoom out a little bit. Okay, so I'm gonna leave this up on the screen for a little bit for you all to try it. I just need to pop to the bathroom real quick. When I come back, we'll start, right? But if you wanna go ahead, you you're comfortable doing that? Okay. I'm not sure what that symbol is. Oh. Oh, we have any Hollow Knight players? I only got into it last Christmas. Yeah. All right, guys, let's take a little swing at these. Right, so Harish works at a call center for 35 hours each week. He's paid an hourly rate of $11.20. Calculate the amount of money Harish earns in a 4-week month. Okay, cool. So, oh wait, no, I didn't check your stuff yet. Sorry. We'll do that quick. Um, Yeah, Noah, you in gradient mode. You see to the top of your calculator, you see in grad. Okay, give me 1 second. Okay. Oh, right. So Noah, on your right hand side, right? So the very top right is the on. If you go down, you have the mode, and then you see in reset, and under reset you see in DRG. Press that DRG button once, and that should change from grad to degrees. Let me know if that works, right? All right, brilliant. Okay, cool. Right, so calculate the amount of money Harish earns in a 4-week month. Okay, so he works for 35 hours each week. He's paid an hourly rate of 11.20. So per week, Harish would earn 35 multiplied by 11.20. That's per week, right? And then you can multiply that by 4. All right, so 35, but if you had, okay, hold on. Right, so if there's no sign in front of it, it's positive, yes. How is it attached to the thing next to it? Is it being added to it? Is it being, right? So that item you're moving is the, what, let's say it was a 4, right? Let's say it was 4 minus x. If you're moving the 4, yes, you subtract the 4. Yeah. Because you're subtracting the x on that side. So if you're moving the x, you'd have to add the x. Right. So 1560. So 1,560. All right, cool. Right. Now, in a certain week, Harish works 8 hours overtime. Overtime hours are paid at 1.5 times the usual rate of 11.20 per hour. So find the total amount of money Harish earns, is paid for in that week. Okay. Okay, cool. So let's do orange. Sorry? Oh, okay. Right. So the overtime, right, sorry, the total would be equal to the basic, right? The basic amount, sorry, is a week, right? The total would be equal to the regular plus the overtime. So the regular, so in 1 week, right? He works 1 week. So he works 8 hours overtime in that 1 week, right? Are you gonna, is this CXC? Okay, this is CSEC maths, regular CSEC maths. Okay, cool. So he would, so he works 35 hours per week by 11.20 per hour, right? The overtime, right? So he works 8 hours overtime. The regular hour is 120, but the overtime rate is time and a half, right? 1.5 times. So you have to multiply that by 1.5. All right. So 35, that's 350 plus 35 is 385. 385 plus 7 is 392. Let's double check that, right? Right. And then 1.5 by that, so that's 12. So 11 by 12 is 132. 132 plus 2.4 is 134.4. Let's double check that too, right? Right. So 8 by 11.20 by 1.5, 134. Right, cool. And we're going to add those two things together. So we need, what, 8 from that to make it 400. So 400. So 526.4. Let's see. Yeah, 526.4. Okay. Okay. Okay, we okay with that? Any how we feeling with that one? Any questions? Are we good? Good? All right. Okay, more online guys. All right. So D'Angelo, Donovan, Liam, Logan, and Noah. If you guys are good with this page, just give me a quick G. All right, brilliant, lovely. Thanks very much. Let's move on. Just now? Okay. This is Alia. Is it Alia or Alia? See an extra Y. I'm not custom seeing a Y there. But I have a friend whose name is Aliyah with A-L-I-Y-H. All right, cool. So you're from Mrs. Aliyah, or elsewhere? All right, we good? Where you get the 1.5? Right here. Right? Overtime hours are paid at 1.5 times the hourly rate, and 1.5 is 1.5. So you can write 1.5 or 1.5. All right, Kelly? All right. Trini, all right, lovely. Trinidad in the house. That's where I'm from too. All right, so guys, so we went to the algebra. Right, so I'll give you guys a minute or so to work what's on the screen or get a little head start, and I'm going to jump in. all three, all share in one packet. All right, and it was it's pepper. What it is? I want to, but I don't know any sauce. Any sauce? And something else. I am a CXC student needs help. Feels them sugar. That's what the song. That's what you're getting from the song. All right, cool. Well, that's what I'm trying to do. Trying to provide some help. You can also check my YouTube channel. I've been leaving my lives up there for a couple of days, so you can go and check and see. I have some math lives up there. I need to start making short content. I really have some ideas. I just need some help editing all that short content. I can make the editing time. I am getting. I right now have 10 videos to edit from for POA for all the 2024 past papers. And the same as this one, adaptation. All right, guys, let's go. Okay. So 4 over 5x by 15x over 16. Right. So 4 goes into 4 one time, into 16 4 times. X will cancel with x one time. 5 into 5, 1. 5 into 15, 3 times. So our answer here is just 3/4. All right. We got 3/4 for that first part there, for 2 part A. All right. Now solve this inequality. All right. So to solve the inequality, just kind of imagine this is an equal sign and then just transpose, right? So what we're going to do, we're going to get all of the, let's get all of the, what you call it, all of the algebra to one side. So let's get that to that side, and then the integers go to this side. I'll work this two ways because there are a couple of little things you could do here, right? You're supposed to get the same answer regardless. Okay. Oh, thanks for liking the life. Right. So here, we're subtracting the 8m here. To move it over, you have to do the opposite of subtraction, which is addition, right? So when you carry it over, you're going to get 8m minus 4m. And the 12 here is pot. So that's kind of what we were asking about, right? I'm going to do that next. I'm going to do it two ways. So I'm going to do this. Yeah. But there is a trick in one of the ways that I had to show you. Right? And not. Sorry? Which sign? Or the inequality sign? Yeah. Right. So this 12 here is a positive. So if you have to get rid of it or carry it over, you're going to have to do the opposite of that, which is subtract. 8m minus 4m is itself 4m, less than equal to minus 7. And to solve for m, you have to remove the 4. How is the 4 attached? What operation? Multiplication. And to remove something attached by multiplication, we use the opposite operation of division. And whatever happens on one side must happen on the other side. M would be less than or equal to minus 7/4, right? Okay, so I did say I would show you the other way. Oh, that's a little too heavy. Let me see if I could get a lighter with. Right, there you go. Right. So if we go 12 minus 4m less than equal to 5 minus 8m. Okay. Yeah, I do not second. So if we choose instead to move, let's say we put that across there and move this on that side, right? So the 5, right? So we're not subtracting the 5 on the right hand side, right? We're subtracting the 8m. So the 5 is actually, there's no sign in front of it, so positive is understood, right? Which is the same as kind of adding. I mean, if you think about it like that, but not really. Anyway, but to move the 5 across, you have to minus 5 from both sides of the equation, right? And similarly, you're subtracting the 4m on the left side. So to move it to the right side, you have to do the opposite operation, which is addition. Right, 12 minus 5 is 7, which is less than or equal to minus 4m. Now, there's the trick. There's the trick. You see how we have a minus 4m here? If you want to solve for m, you're going to have to remove the minus 4. How is it attached? By multiplication. To remove it, you have to use division. But the thing is, in inequalities, if you are ever multiplying or dividing by a negative term, you have to flip the sign. Right? So what's going to happen here is you're going to have 7, or minus 7 over 4 greater than or equal to m, which is the same as this. It's just laterally inverted, horizontally flipped. So both of those mean the exact same thing. Both of those are correct. But always remember, with inequalities, sorry, Noah. That's not. Right, okay. Cool. Right. Right, so to solve for m, I have to, oops, sorry. Right. To solve for m, I have to get rid of whatever's attached to it. Right now, what's attached to it is a 4. And the 4 is attached to it via multiplication. And to remove something attached by multiplication, I have to use the opposite operation, which is division. So you could actually just put divide by 4 like this, and then get m less than equal to minus 7 over 4. But what I opted to do was to show the long working, or the more explicit working, which is where I showed the division by 4 on both sides of the equation, right? Which is what they don't usually show you in school. They teach you the shortcut, right? So when you cancel here, right, you just get back the same answer like that. Does that help? Does that make it a little clearer? All right, cool. All right. Ladies, we okay with these first two algebra pieces? All right. Google Meet, just give me a quick G if you're all good with the first page now on the algebra. Thanks. Please. Right, if you need me to re-explain it, give me an R. Right. I think Noah said he was good. All right, lovely. Okay, bills and sugar. Nice. Okay. Okay, so this one. So this is a mix algebra and some geometry here. So we'll take a little read and I'll give you a minute or two to see if you can try something, right? So the diagram below shows a compound shape, LMNPQR, made from two rectangles. So you can either think of it as this rectangle plus this rectangle, or you could think of it as this rectangle plus this rectangle down here. Or maybe it was two rectangles and this is a common area where they overlap in. But we don't know. We don't really know. It doesn't matter. All right. The lengths in the diagram are written in terms of x, are in centimeters. So we have 4x minus 5 is the whole horizontal here. Right. This is x plus 1 here. Now, there's an unknown piece there. Right. Also, the full vertical is 3x. On this side, we have piece of it, and we're missing, well, we're not missing, it's across here, right? So we have two missing pieces. So let me get some colors going here, right? So you're asking for PQ and for RQ. So we put PQ in pink. Okay, that pink not showing up very well. Okay, so right. Let me just come to this side. So PQ Right, that's a little better. And then we'll do the other one in green, right? RQ. All right, so we want to find the pink length, PQ, and the green length, RQ. All right, so again, I'll give you a little minute head start for those who think they know what to do. And the rest of you who are not sure what to do, what I would suggest is you can sketch out the diagram real quick, right? Hey, Vito, how you doing? Oh, wow, 19 people watching. Wow, that's pretty cool. Kelly, Chantel, Ivy, Dree, Shan, Unknown. You love Blue Waters, boy. I like that one. I like real Blue Waters. Zakir, Yamada, Ramlal, Suplam. How you doing? Nick X, Jan. Hey, Deja, how you doing? Right, thanks for joining, you guys. Appreciate it. Oh, thanks for the follow. Wait, where's Jabari? I don't see Jabari there. What's going on? Shameless. Good to see you. A chord is a chord. That first piece there, that's a chord. The radius must start from the center of the circle. A chord, C-H-O-R-D, a chord. No, but you joined in December, right? And we would have done circle geometry before that in November. So she was never for that particular section. All right, cool. All right, let me take a little swing there, guys. Okay, to find PQ, we acknowledge that it's a vertical line, and we have the whole vertical is 3x. This piece here, right, which runs there to there, is the same as that, right? So this piece is x plus 3, right? So this piece, the pink one down here, right? If you think about it, let's just call it A for now, right? So this plus this must be equal to 3x, right? So, so A plus x plus 3 must be equal to 3x. Right? We could replace A. If A is confusing people, just put PQ. Right? So PQ, the pink piece plus the blue piece will give us the full vertical, right? So now to solve for PQ, we're going to shift the whole expression x plus 3 to the next side, right? So you can say, therefore, PQ will be equal to 3x minus x plus 3. And when you drop your brackets, remember you're subtracting both things on the inside, eh? And 3x minus x will simply give us 2x, right? So this pink piece here is just 2x minus 3. Right? So again, what I did was I observed the full vertical here was 3x, right? And then what I'm looking for is this piece of the vertical. So what I did was I said, okay, look, right? This unknown piece here, well, not unknown, is actually the same as that x plus 3, right? So this is x plus 3 here. So x plus 3 plus this piece, right, must give me 3x. So that's what I did here, right? And then after that, I simply, right, I can't see, oh, sorry. Hold on 1 second, I'll see if I can fix that for you, right? Jabari, and when you add it back, you get 3x. So correct, yeah, okay, good thing. So Jabari, yo. Give me a second comment. I'll come in. Yeah. So what Jabari said is if you add this and this, was it what the polygon rule? What for the is some of the angles inside? Yeah. 180 multiplied by n minus 2, where n is the number of sides. Wait, hold on, which question are you on? 3B. 3B? Okay, Each interior angle of a regular polygon is 160. Calculate number of sides. Okay, so interior means inside, right? 160 is pretty big. Imagine, so what the word regular means is that all the lengths are the same length, right? So for example, if it was a triangle, we call it equilateral. If it was a, well, a quadrilateral, it would be a square, most likely, right? You could have a regular pentagon, right? So what you could do is you could actually check each one and go up one by one, right? So for example, if you had a triangle, that's three sides, right? And the degrees, it'd be 180. 180 divided by 3 is what? That's 60, right? In a square, any quadrilateral is 360, right? 360 divided by 4 is 90. For a, what you call it? A pentagon, right? So this is three sides, this is four sides. So for a five-sided figure. But just by the way, right? So we could go 5. So with 5 now, if you have 5 minus 2 by 180, right? That's 3 by 180. It's 540, right? So 540 divided by 5 would be equal to 108. So now what's going on? Yeah, so we could go up one by one, but as you could see, we kind of climbing slow, right? So what you could do maybe is you could jump a little bit. So let's try 10. Let's offer kicks. Let's just try 10, right? So if we do 10 minus 2, that's 8. 8 by 180, that's 800 plus 640 is 1440. But if you take 1440 and divide by 10, we still get 144. So try 11 more 12 and see what you get. Okay, so good. Huh? It's a valid way of working. It's not efficient, but it's effective. All right? All right, sorry, I'm going to go back to the algebra. Sorry. We're going to finish
it. Tricks, right? I can't remember how to do this at all.
All right, so you remember your three basic equation, right? So relative to the angle you have, this is opposite. That's hypotenuse. Right, so SOH. Which one was 3B?
SOH?
Yeah, sine is opposite over hypotenuse.
Oh.
Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Right. Okay, sorry, the I think it's cool for the hallway. Google Meet just came on a minute. Yeah, 180 degrees multiplied by n minus 2. Yeah, but you can skip. You can skip until you get to. Oh, okay. Okay, where I'm from, Trinidad. More specifically, Diego Martin. Yeah, anything else?
No, I don't remember like how to do this.
Sine of the angle is equal to opposite over hypotenuse. We'll start with this, and then we'll across here. We divide it. Oh, sorry. Right. So sine is equal to opposite over hypotenuse,
Yes.
right? So we're dividing this by that, which means that if you want to solve the numerator, you have to multiply by the denominator. So you'll have sine 38 by 18.
Oh, that's it?
Yeah.
Okay. That makes my life so much easier.
Oh, okay, what's going on? All right, sorry guys, let's go back here. Right, so that's that. Now to find RQ is green, right? Okay, so let's clear off some of the annotations there, right? All right. So the full vertical. Let me show you. Okay, cool. Right. So 4x minus 5 is the full horizontal, right? This piece, so you're looking for the green, but then this piece here, right, is x plus 1. So x plus 1 plus the unknown is 4x minus 5, right? So if you add these two pieces together, we're supposed to get that, all right? So let's make our statement. So RQ plus x plus 1 is equal to 4x minus 5. right? So now we're going to subtract x plus 1 from both sides of the equation, right? So that's equal to 4x minus 5. So check it. You could put it in your regular place, right? Anybody ever try putting it vertically? Minus x plus 1. So 4x minus x is 3x. Minus 5 minus 1 is minus 6. So r cubed is equal to 3x minus 6. So this is 3x minus 6. All right. Okay. Sorry, I should put that in the green to kind of match with the Yeah, you got the 3x minus 6. All right, good. All right. Okay. Google Meet. If you guys are good with what's on the screen currently, just kind of give me a quick Genie chat. For PQ, how did I get x plus 3? Give me 1 second. I just looking for some feedback from the class, right? I'll check it back this time. All right, Donovan. Right. Again, if you need me to re-explain, give me an R. Okay. Okay. So the question was how did I get the x plus 3? That's this piece here, right? Because what I was saying is that remember we want to find this piece here. Yeah. Right. So this piece here is a vertical piece. The whole vertical is 3x. And this piece corresponds to that x plus 3 across there. So that's how I got the x plus. So this piece here is also x plus 3. Right, D? Hope that helps. All right. Sorry. Yeah. Talk to me. Right, because you did minus 5 plus 1. If you do minus 5 plus 1, you get minus 4. But remember, you're minusing the whole x. Hold on. So when you drop the brackets, Khalifa, right? Remember, you're minusing everything in the bracket. So you have 4x minus 5 minus x minus 1. Let's rearrange and put together the algebraic terms and put together the constants. 4x minus x is 3x. Minus 5 minus 1, they're both negative. So you add them and put back the minus sign. Right, because you're subtracting x plus 1. So you're subtracting x and you're subtracting 1. Yeah, I know. So that's if you put minus 1, if you put minus 5 plus 1 equal to 6, then you might get the mark for the week, yeah? Yeah, Jabari, May 2023. Thank you, Shan. Thank you, Deep. Sorry? Okay. All right, cool. All right, guys. So the last thing they're asking us for is, given that the total area of the shape is 414 square centimeters, show that x squared plus x minus 72 is 0. Right. So let me go back to the previous page because we need to see the information there, right? So I'm going to actually copy and paste this page, right? Right. Leave yourself. Okay. Okay. I'm trying to find white space to write, but I don't really have any space to write. And do my calculations. Okay, check this, right? Total area. Let's go in a blue, shall we? I don't want that size point. I want a slightly lighter point. Right. Right. No. Right. So total area. Sorry, Dahlia, do you do in-person lessons in price? Yeah, I do. Okay, so it depends on what lessons you want. The price difference, right? So for my Form 5 maths classes twice a week, it's 640 TT for the month. The Form 4 classes are once a week, that's 400 for the month. One-on-ones differ, but they usually cost more. All right, so the total area is 414 square centimeters. Right. Now, to find the total area, we have to break up the shape into 2 rectangles. So you could either do it like this, as in rectangle 1 and rectangle 2, or you could do it like this, rectangle 1 and rectangle 2. Right? Now, it doesn't matter which way you do it, it's the same shapes and the same area. Right? So, you all have any preference as to which way you want to do it? Cut it across? Okay, cool. So the area of this section here is that by that. Would you agree? Right? It's a rectangle. And the formula for the area of a rectangle is equal to length by width. It doesn't matter which one you put first, we're multiplying the two of them. And with multiplication, it's commutative. So x by 4x will give us 4x squared. Hold on. Let me actually shift this on the outside, right? Right. X by 4x is 4x squared. X by minus 5 is minus 5x. 3 by 4x is 12x, and then 3 by minus 5 is minus 15. Simplifying the terms in x will give us 7x. And minus 15. Okay, width or breadth. Yeah, width or breadth, that's correct. Right, and then down in the corner, right, we have, so the pink is 2x plus 3, and this is x plus 1. So let's multiply those together. 2x plus 3 by x plus 1. So 2x by x will give us 2x squared. 2x by 1 is 2x. 3 by x is 3x, and 3 by 1 is 3. So everybody be writing. And then 2x plus 3x will give us what? 5x, right? So 2x squared plus 5x plus 3. So now, what we're going to do is we have to add these two together, right? And when we add those two things together, we have to put it equal to 414. All right, so let's see if I can fit that here. So 4x squared plus 7x minus 15 plus 2x squared plus 5x plus 3. Minus 15 plus 3 is minus 12. 7x plus 5x is 12x. 4x squared plus 2x squared is 6x squared, right? Right, now we have to put that equal to 414. So 6x squared plus 12x minus 12 is equal to 414. And now we're going to bring this across by subtracting it from both sides of the equation. We have 6x squared plus 12x minus 12 minus 414 is equal to 0, right? So that's just going to simplify to 4x squared plus 12x minus 426. And then we notice that everything is kind of divisible by, what do you call it? Yeah, sorry, you're correct, 6. If we divide by 6, let's see what we get. Hold on. We're not gonna get what they want though. 72. Okay, so if we divide, okay, so something is wrong somewhere. Oh, hold on, sorry, just now. If anybody's seen the error, let me know. If we divide by 2, you end up with a half x squared. Okay, hold on. Let's just back up a little bit, right? All right, hold on. So PQ plus x plus 3 is equal to 3x. Let's jump back. So we have 2x minus 3, right? Okay, cool. That's x plus 1. Right, we didn't cut that, so we did, okay, we did 4x minus 5 and x plus 3. 4x squared, 12x minus 5x minus 15. Right, 4x squared plus 7x minus 15. Okay, cool. And then 2x plus 3 by x plus 1. 2x squared plus 2x, 3x plus 3. That's 5x. Okay. And we have to add those two things, right? That's 6, that's 12. Minus 15 and 3 is minus 12, right? Okay. And then 414, that's 426. If we divide by 6, we get x squared plus 2x minus 71. Yo, a half AB sine C. All right, hold on. Let me check and see what happens in 24 because oh, 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 that's 2x minus 3, right? What I have here? Plus. Wow. You'll get marks for working, yes. All right. Sorry, guys. Wow. Right. So let my mistake be a lesson for you, right? Wise people learn from the mistakes of others. So my mistake was not double checking my working. So 2x by x is 2x squared. 2x by 1 is 2x. Minus 3 by x is minus 3x minus 3 by minus 3. 2x minus 3x will give us minus x. Right. So now, again, we're going to take that item. Right. So we're going to take the two areas. So we have 4x squared plus 7x minus 15. And we're going to add 2x squared minus x minus 3. Right. So 4x squared plus 2x squared is 6x squared. 7x plus minus x is 7x minus x, which is minus 6x. And then we have minus 18. Aha! This, we will get it right. So, of course, this is equal to 414, right? Right. So when you bring over the 414, you subtract it. So you're going to have 6x squared minus 6x minus 18 minus 414 for the 0. So you have 6x squared minus 6x minus 432. And now we notice that all of the coefficients and the constant are all divisible by 6. So we divide by 6. 6x squared divided by 6 will give us back x squared. 6x divided, well, minus 6x divided by 6 is minus x. And then if you divide 432, you get 72. Right. And that's where you stop. So don't solve the quadratic because that's not what they asked us to do. All they asked us to do is show that that is equal to 0. And that's what we did there. All right, yeah, guys. So you see how a silly mistake could cost your time? Yeah. Oh, okay. Oh, yes, 21. Wow. Okay, so they'll give it a couple minutes to kind of just level out, right? All right, the x sim is positive. Oh, it is? Oh, it is. Yeah, sorry. Wow. Thank you, Sleepy. Well, clearly, I'm more sleepy. Well, you are sleepy, apparently. Clearly, I am sleepy. I'm missing that. Yeah. Guys, I apologize. Yeah. Yeah, when I say sleepy, I'm not joking. Yeah, was he live yesterday? I'm confused. Who's that? Me? Yesterday was on Tuesday. No, I wasn't live yesterday. It was Monday. Yeah. Give me the name again. Sorry. What was the name? Was it an A? Was it an A? Is it a pixie? What you confused about? What you confused about? All right. All right. Fellas on Google Meet, if you guys are good with that, so D'Angelo Donovan, Liam Logan Noah. If you guys are good with what I just did, give me a quick G. All right. Vectors. I did vectors already, boy. So you have to put the little box thing because it's show. You can put it. If you don't put it, it's not a big deal. Once you're working, it's clear and easy to understand, easy to read. It's kind of obvious. So I don't think it'll cost you a mark or a half mark if you don't put the box. But if you want to put it, you can. All right, ladies, we okay with the working for the area? Yeah. Okay. All right, we're on to question 3 now. Okay. Can we see everything that I am seeing? Yes. Yeah, but yeah, Mara. I'm trying to see if I could do a series of shorts on specific topics. And vectors is actually near the top of the list for me to do the shorts, but it's just the time to record and then the time to edit. That's the problem I have. If I can get somebody to help with that, specifically the editing and the uploading, I think we're in business. But right now, but you can see from what channel I have now. I have more recent replays up for the past papers. So look for like the last days. You see the vectors there. Right. Look for Monday. Monday should have some vectors. Okay. Diagram below shows a semicircle with diameter AC. So this is a diameter of a semicircle. That's the center somewhere there. B is the point on the circumference, and AB is equal to BC. So AB is equal to BC, right? And we can kind of tell that because you have a little stroke, a little dash on the line, right? Now, apart from the fact that they tell us it is a semicircle, what do we call this shape? And if we have two lengths equal in the triangle, what more specifically? It's isosceles, right? Now, on top of that, because it is a semicircle and we've built a triangle on the diameter, there's a rule that says if you do that, such that all three vertices of the said triangle touch the circumference, we have a right angle triangle. Now, state the geometrical name of the line AB. The line AB is a chord, C-H-O-R-D. Now, they wanted to find the value of the radius of the circle. So the radius is the distance from the center to the circumference, right? And radius is equal to 1/2 of the diameter, right? Or diameter divided by 2. So we could try to find the diameter. So here's my question, right? What thoughts do you have about finding the diameter? You think? Well, right here. Radius is equal. Yeah. Well, a radius is double. Sorry, a diameter is 2 radii back to back. So a diameter is 2 radii. So 1 radii is half a diameter, right? Now, because we know it's a right angle triangle, and because we know it's isosceles, we know this is 45 because the sum of the interior angles of a triangle is what? 180. If we have a 90-degree triangle, the remaining two angles must sum to 90 themselves, because 90 plus 90, 180. And if you have an isosceles triangle, the two angles must be equal as well. So if you split 90 into two equal pieces, you get 45 degrees each, right? But to do that, you'd have to use probably like SOHCAHTOA or something, right? We could use sine, because sine 45 would be equal to opposite over hypotenuse. But there's another way we could do this. This is also 8.2, right? This is a right angle triangle. What name do we give to the length opposite the right angle? The hypotenuse, right? And whose theorem do we normally associate with right angle triangles in Pythagoras? Very good. And what does Pythagoras' theorem tell us? What does Pythagoras' theorem tell us? Right? Right. Pythagoras' theorem tells us that the square on the hypotenuse is equal to the sum of the squares on the other two adjacent sides. So, they do. Hold on. Oh no, sorry. The formula sheet somewhere. But I think I delete mine. Oh, look at here. Look. Right, look. Oh, that's cosine rule. Where Pythagoras? Yeah. I guess you have to know Pythagoras. But cosine rule is Pythagoras with a modifier. But anyhow. Where was I? I was there. Okay. So how you get the sorry. Can I ask a question? Right, the 45. Right. Okay. So we know it's a 90-degree triangle because this is a diameter in a semicircle. And they built a triangle on the diameter. And the rule is that the angle in the semicircle is 90 degrees. So if we have a triangle, the single 90-degree angle, the remaining two angles must also add up to 90 degrees, because the sum of all three angles is 180. So if I know that we have a single 90-degree angle here, and these two must add up to 180, on top of which they are equal, because we know it's an isosceles triangle. So not only are these two lengths equal, the angles to which they are opposite are also equal. Right? So if these two must add up to 90 and they are both equal, 90 divided by 2 is equal to 45. Right? So you could use tricks. You could use sine, you could use cosine, you can't use tangent. That one not gonna work, right? Tan is equal to opposite over adjacent. And we make a difference. So tan, well, tan and 90 is undefined, so we can't do that. Okay, cool. Right. So we could use Pythagoras' theorem to find the diameter and then find half of that. Right? So the diameter squared is equal to 8.2 squared plus 8.2 squared. Right, so let's take a look at that. $134.48, right? So that's 134.48. So to find D, you have to square root that. So about 11.6, let's round it up, 11.6, right? And therefore, to find the radius, we now have to divide. Right, so just to double check with Pythagoras' theorem, we could use the length 8.2 and 8.2, square those, add them together, get 134.48, square root that, round it off to 11.6, and then that's the diameter, which is the full line AC. But we want a radius, which is half of the diameter, right? Remember, a radius starts from the center and goes to the circumference in a straight line. All right, cool. Oh, thanks to the follower. I appreciate it. Sorry. Yeah, okay. Ladies, are we okay with what's on the screen here? Any questions? All right, so Leandro Donovan, Liam Logan, and Noah, if you guys are good with that, just kind of give me a G in the chart. If you need me to re-explain, give me an R. Melanin shrinking. All right, cool. Okay, cool. We're going again. All right, so this is what I was explaining to the other class just now. Okay. So each interior angle of a regular polygon is 160 degrees. Calculate the number of sides of the polygon. So a polygon simply means a shape with a certain number of sides, right? We don't know. If we take a triangle, that's 3 sides. If we take a quadrilateral, that's 4 sides. If you take a pentagon, that's 5. All right. Take a hexagon, that's 6, etc. Right? Hi there, just wait. I like math. Okay, love that. I like math. Right. Yeah. Now, for each of these, so this is 3 sides, that is 4 sides, that's 5, that's 6, right? Now, a regular polygon means that all of the lengths, the side lengths, are equal, right? So they're equilateral, right? And they want a number of sides. Now, they've given us the measure or magnitude of one of the interior angles. Now, there's a formula you could use to find the sum of the interior angles of any given polygon, right? And that formula is 180 multiplied by, now you could use N or you could use S. S minus 2, where S is the number of sides, right? So for a triangle, how many sides does a triangle have? 3. What's 3 minus 2? 1. What's 180 by 1? 180. And that's the sum of the interior angles of a triangle, right? And if we took 180 and divided by 3, we get 60 degrees. So if it was an equilateral triangle, a regular triangle, that's what regular means, that all the sides have the same magnitude, and all the interior angles also the same magnitude. That's how we find the measure of each interior angle. You take the total number of degrees, the sum of the interior angles, and divide by the number of interior angles, right? Now, what about a quadrilateral? That's 4 sides, right? 4 minus 2 is what? 2. 180 by 2 is equal to 360. And if you wanted to find the value or magnitude of each interior angle, you take 360 and divide by 4, and you get 90 degrees. And if you think of a square, all 4 angles are right angles. Really for you, okay? You sure? All right, cool. If we took 5 for the pentagon, 5 minus 2 is 3. 180 by 3 is 540. And if we take 540 and divide by 5, we get 108. And so we'd go. But look at the number that they give us here, 160. So it means that we clearly need more than 5 sides. I would make it the same, maybe even more than 10, right? So you could always test that, right? You can say, okay, instead of 6, let's just jump to 10, right? So if it was 10, 10 minus 2 is what? That's 8. And 8 by 180 is 1440. But then if you take 1440 and divide by 10, you only get 144 degrees. But I feel like we're not far. Let's try 12 now. So if you do 12 minus 2, you get what? You get 10. And 180, sorry, I said 10. Right? And 10 by 180 is 1800. So if we take 1800 and divide by 12, what do we get now? I don't know. No, I feel like you get 150. Yeah, 150. All right, so what do you want to try? You want to try 14 next? Let's try 14. 14 minus 2 will give us 12. 12 by 180. I think that's 2160. Please feel free to double check my maths. 2160 divided by 14. Let's see. Oops, sorry. Hold on, just now. 180 by 12. Sorry, let me check that again. 2160 by 14. 154. Okay, so maybe 15. Let's try 16 just in case, right? 16 minus 2 is 14. So 180 by 14 is that. Divided by 16 is... It's creeping up here, boy. Wow. Okay. So I guess we could try 18 now. So then that's 16, right? 180. Oh, sorry. There you go. So it's an 18-sided shape. Wow. Now, what we did there took real long, right? So there has to be some sort of shortcut or some sort of thing we could apply. But if you did it that way, you'd still get the marks, yeah? But again, how many marks a game? 2 marks. All right, see? So it obviously can't be a whole set of work here. So how can we shortcut this? Okay, math is a study of pattern. What was the pattern we did? We took 180, multiplied it by s minus 2, right? That gave us the total number of degrees on the inside, right? And then we divided that by s to find the measure of each angle. Now, this is supposed to be equal to 160. So we could use that formula. Let's check it. Now, we know the answer is 18, right? Okay, cool. So, right? Oh, crap, hold on, sorry. Let's change the thickness at that point. All right, so we took 180, multiplied it by s, which is the number of sides in the shape. Right, and that gave us the total number of degrees in an interior, right? And then we divide that by s, the number of sides, and that's supposed to give us 160 degrees. Right, so to solve here, the first thing I do is I'll clear out my denominator. How do I get rid of a denominator? Yeah, it is a little tricky. I agree with that. How do I get rid of my denominator? I multiply by it. Because I'm currently dividing by it, not so? So I'll multiply by my denominator on both sides of the equation, right? So now I have 180 degrees by s minus 2 is equal to 160s, right? Now let's multiply the 180 by s minus 2. So you use distributive law. So you'd have 180 s and 180 by 2 is 360, right? So now let's bring this across here and bring the s's on one side, right? So I'll minus 160s from both sides to carry it from right to left. And I'll also add 360 to both sides to carry from left to right. So I'll have 180s minus 160s is. And to solve for s, I have to move the 20. How is the 20 attached to the s? So to remove it, I have to divide. So when I divide by 20 on both sides, that's correct. You have to reason. That's correct. Yeah. Oh, thanks for the follow. I appreciate it. And just take some time. Yeah. Right? Knock out the zeros, and 2 into 36 goes 18 times. So a little shorter. Right? But again, if you're not sure how to do it that way, you have to do what you know. All right? Yeah, the reason. All right. Okay, so my fellas on Google Meet. So D'Angelo, Donovan, Liam, Logan, and Noah. Just give me a quick G if you're good with that. If you need me to re-explain, let me know. It's not a problem. I don't mind. Oh, next one. All right. You guys got 18 for the three part B. The shape. Remember when I had to find how many sides? Right, but you saw how I did it here, right? Well, even if you guess it, you gotta show that it's the right answer. Right.
And I realized it with I was like, yes,
yeah. All right, cool. All right, I can switch pages now? No? Yep, all right. No problem. All right, so we have a kind of transformation thing here, right? So the diagram below shows a trapezium A. So that's a shaded region there, drawn on a square grid. Okay, so the quality of the paper is not the best, so I do apologize, right? Now, what I want us to do, on the diagram above, draw the image of A after it undergoes a reflection and a translation. So I don't think these things are supposed to be like one after the other. Yeah, I think it's separate ones. Okay, let's do part 2 first. Part 2 is actually easier, right? So part 2 says a translation with vector 4 minus 7. A translation is something that's called a shift, right? Oh, thanks, Ali. Right? So 4 is what we call the horizontal component. That's how many spaces left or right. And if it's a positive horizontal, we are going to the right. The minus 7 is the vertical. Now with verticals, positive movement goes up and negative movement goes down. Right? Now, all you have to do is draw the image. You don't have to show any working, but you could, right? So let me see if I can help you. So we have to go 4 spaces to the right and 7 spaces down. So check it. You could take any. So let's say we had. Oh, come on, man, Philip. Right. Right. So that's B. Let's call it B, C, D, E. You can take any of those points. All you have to do is shift one point and then redraw the shape. Let's shift point B, right? So you're going 1, 2, 3, 4 spaces to the right, and then 1, 2, 3, 4, 5, 6, 7 down. So your shape is down here now. So basically what I mean when I say redraw the shape, look at the shape, right? From B to C is one horizontal, right? So you have one horizontal there, and then you have two verticals going down like that. So 2, and then you have two horizontals going across there. So you're drawing those two. And then you just finish by closing up with the diagonal. And that is A double prime. Hey, so how you doing? Right? Now, the reflection in the line x equal to -1. You know what? Let me actually copy and paste this page so we could actually see it a bit more clearly and not with the visual clutter. Okay. Now the line x equal to -1 is a perfectly vertical line that runs through -1 on the x-axis. And when you reflect in a line, right? Okay. So let's say I took let's say this point first. Let's call that point C. Right? That point, if you go perpendicularly, right, is 1, 2, 3 spaces away from the mirror line or the axis of reflection. So its reflection must be the same perpendicular distance on the next side. So that's C. Yeah. Yeah. Right. Bearings and signposts. Yeah. I don't know if I have that one compiled, but I have the other two. So just send me WhatsApp and I could organize that. All right. Right. Now, when you do this, you could again just draw the shape out. But if you want to see the other ones reflected, if you want to understand the principle, we'll do our next one, right? This point here. This point was just 2 spaces perpendicularly away. Right? Yes, if you at the next one, right? So the reflection of this point will be 2 spaces on the next side, right? The same distance on the opposite side of the mirror line. So that's C prime, let's call that one D prime. Right? What about E? All right, 1, 2, 3, 4. So its reflection will be 1, 2, 3, 4 away on the opposite side. All right, and we forgot this point on top of here, B. So B is 1, 2, 3, 4 away, and then on the opposite side, its reflection will also be 4 away. All right, so we're just going to connect the points, and we have A prime. Okay, cool. When you're reflecting, right? Huh? Reflect the, yeah, so sorry, reflect and then shift. Okay. Oh, no. Oh, no. You did the line x equal to y. That looked like what was it? X equal to -1 is a perfectly vertical line. When we did linear programming in January, we did on that line. So any line that is just x equal to something is a perfectly vertical line running through that number on the x-axis. All right. So the Andrew Donovan, Liam, Logan, and Noah, if you guys are good with these 2 items here, the translation, sorry, and the reflection is going to happen Gina. All right, so that's the reflection in x equal to -1, and that's the translation with vector 4 - 1. All right, CPU, good job. Okay, cool. All right. So we're going to try to see if we can finish question 4. All right, so we have some function. Not everybody's favorite. Right, so here's what I'll do. I'll give a minute for anybody who wants to see if they could try it on their own, right? This, by the way, is x squared plus 1. Yeah, okay. I agree, but not everybody feels so. Much to my surprise, but that's... Is it too small? If it's too small, I'll zoom back in. Sorry. CPU. All right, just now. 1 second. Right. Let's go. All right, so what does it mean? What does it mean when a function is undefined? That means that the denominator is equal to 0. Right? So for what value of x is f of x undefined, means we have to let x plus 2 equal to 0. And to solve for x, we simply have to subtract 2 from both sides of the equation. So the value of x for which f of x is undefined is the value of x that causes the denominator to be equal to 0, which in this case is minus 2. Okay, now find the value of g of a quarter. So all we do with that is we simply substitute a quarter inside of the g function for g. Sorry, just give me 1 sec. Things just kind of all over the place right now. Okay. Right, so it's 4 by x, which is in this case 4 by a quarter, and minus 5. 4 by a quarter is 1. What? And 1 minus 5 is simply minus 4. I substituted a quarter inside of g. Right. For when a function is undefined, that means the denominator is equal to 0. Dividing by 0 is called undefined because of what division is. Division is repeated subtraction of the same number from another number until we can't subtract that number anymore. For example, if I said 6 divided by 2, we know the answer is 3, but what does that mean? If we did 6 minus 2, we'd get 4. 4 minus 2 is 2. 2 minus 2 is 0. So we can't minus 2 anymore. We have nothing left. How many times will we be able to minus 2? 3 times. If we did 6 divided by 0, 6 minus 0 is 6. Minus 0 is 6. Minus 0 is 6. Would this ever end? No. So people say it's infinity, but that's a misnomer, right? Well, it's incorrect to call it that. So we call it undefined because we can't complete it, we can't finish it, we don't know what it means. Right? How do you divide something by nothing? Okay. So when they ask you for what value of x is the function undefined, you put the denominator equal to 0 because that would be when it's undefined, divided by 0. So when you put that equal to 0, you solve for x. So the value of x, yeah. No matter about it. Right? H of minus 3. H is x squared plus 1. No. Minus 3 squared is 9. 9 plus 1 is equal to 10. Now f of 0 is equal to f of whatever f of 0 is. Now, what's the function for f? That's the 3 over x plus 2, right? 0 plus 2 is just 2, right? So now we have to find f of 3 over 2. Right. 3 over 2 is 1.5. 1.5 plus 2 is 3.5. So we have 3 divided by 3.5. Three and a half is 7 over 2. And when we're dividing fractions, you change divide to multiply and you invert the divisor. 3 by 2 is 6, 1 by 7 is 7. Right. Any questions? Anybody? Anything? All right, good. Okay. What specifically? Do you understand that if they ask for g of a quarter, all you're doing is substituting a quarter inside the function? Right? So if they ask for g of 2, it's subbing 2 inside. So it'll be 4 by 2, then minus 5. 4 by 2 is 8. 8 minus 5 is 3. Right? If they wanted h of let's say h of 6, you'll sub 6 inside of here and place the x. So you'd have 6 squared plus 1. 6 squared is 36, and 36 plus 1 is equal to 37. Right? So that's the basics of the functions. It's just substitution. Okay. You okay with a part 1 with the undefined thing? Okay. So which one down here you want me to re-explain? Okay, so with g of a quarter, the substituting 1 quarter inside of this function here. Right? So everywhere you have an x, you're going to replace it with a quarter. 4x is 4 multiplied by x. 4 by a quarter is 1. 1 minus 5 is minus 4. Right? And they wanted h of minus 3. So you sub in minus 3 here. They have minus 3 squared. When you square something, what are you actually doing? Multiplying it by itself. And a minus by a minus is a plus. So minus 3 by minus 3 is positive 9. And 9 plus 1 is 10. Okay, so you okay with those two? All right, cool. There we go again. Now, they want f of 0. So this is called a composite function. And how you solve it is you go from right to left. So if it was, so it's f of 0. So the first thing you have to do is do this, the first f of 0. So what that means is you're going to substitute 0 inside of here. That'll be 3 over 0 plus 2. 0 plus 2 is just 2. Now you want f of that, so it means that you're plugging that back into the same function, right? That will give me f of, hold on one sec. 3 over 2 is 1.5. 1.5 plus 2, 3.5. So it's a fraction, and the understood operation between numerator and denominator is division. So you have 3 divided by 3.5. 3 is 3 over 1. 3.5 could simplify to 7 over 2. And when we're dividing fractions, you change divide to multiply and invert the divisor. 3 by 2 giving us 6 in the numerator, 1 by 7 giving us 7 in the denominator. That better at all? Okay. My guys on Google Meet, so Liam, Logan, Donovan, Bianca, and Noah. If you guys are good with this page, mark with G, please and tags. Okay, cool. All right, cool. Let's see if you can wrap up quickly for me. So it says here, write an expression in its simplest form for GH. Okay, cool. G of x, that was the 4x minus 5 one. And h of x, x squared minus 1. Minus 1 or plus 1? Right. So this is also a composite function. So what they want you to do, right? They want g, oh, sorry. So gh, so before we were substituting single values inside of functions. Now, if they give you just like this with no values, you have to put one function inside of an x. So what you're doing, and again, you're going from right to left. So gh of x means you want to find g of h. H being the entire function h. Right? So g is 4x minus 5. The x here is the whole function h, which is x squared plus 1. Now, when you expand using the distribute 4 by, all right? Four minus 5 is minus 1. And g inverse of minus 2. Okay, so we do that one. Area of vibes. Yo. Well, they can teach them, but they never ask for it. They'll more ask for that in our maths, although they never ask for that either. It's technically on the syllabus, but they never ask for it. All right, guys. One last one. So G inverse of minus. So G inverse of minus 2, right? So you could find an expression for G inverse x sub minus 2 inside of it. But the easier thing to do if you want G inverse of minus 2 is to put G equal to minus 2 and solve for x. All right. So we're going to let G of x equal to minus 2. Now to solve for x, the first thing I do is I add 5 to both sides, right? 4x will be equal to 3. And then lastly, I'd simply divide by 4. And we're done. Yo. X equal to minus b over 2a. No problem. Right? Alternatively, if you want to do it the longer way, right? So you're going to let y equal to 4x minus 5. And you swap out x and y. Then you'd make, you'd make y the subject of the formula again. Therefore, that is G inverse of x. So now, if you want G inverse of minus 2, you would sub it inside. I said minus 2 plus 5 all over 4. That's true. Which is exactly what it is. So this is the more efficient of the two ways. Okay. Okay, folks. I think we're going to put a pin in it there for today, right? I'm not going to rush to do in any part of 5. When we come on Monday, we're going to aim to do 5, 6, 7, and 8. Right? Which means next week, Wednesday, we'll finish this paper. Alright, so we're just going to continue doing participles up until the exam. And then we're going to hit some multiple choice later on down the line. But somebody today asked about a maths crash course. So I'm like, well, like a good idea. But how I would do mine was, so the POA last year, I did 16 2-hour sessions. That was my crash course. I'm not doing no 12-hour. Forget that. I have a life. Write your name on it. Even here from me. I'll get a folder and put it across there. 6:30 p.m. Trinidad. All right. Fellas on Google Meet, if you guys have any questions and you get to actually in class, what's happening, right? Apart from that, have a good weekend. I'll see you guys on Monday. Bye. 4. All right, later. Yeah, we finished number 4. All right, that's a good page. Can't tell, no problem. Yeah, you're most welcome. YouTube. Ashok. That was it. Yeah, that's right. Okay, anyhow.